Most people treat a large language model like a genie in a lamp. You rub it, you type a prompt, and out comes an answer. But here's the question nobody seems to be asking: what happens inside the lamp? You'll find thousands of prompting tutorials online, but almost none of them bother to explain how your prompt is actually consumed by the model. How much context does the LLM need? Why does phrasing matter so much? Why does the same question sometimes give a brilliant answer and sometimes complete nonsense? It all starts with something called a token. A token is the basic unit of language that an LLM processes. It's not quite a word, it's closer to a word fragment. The word engineering might be one token. Unbelievable might be split into two. On average, one token is roughly 3 to 4 characters, and 100 tokens is roughly 75 words. The reason this matters is simple. Everything the LLM reads, writes, and thinks is counted in tokens. Your prompt has a token budget, and so does its response. But here's the more important question. Does the model understand these tokens the way we understand words? When you hear the word car, you don't process the letters C-A-R in sequence. Your brain instantly conjures an image, a shape, a sound, a feeling of motion. Meaning arrives whole. LLMs work differently. They don't form mental images. Instead, they learn statistical relationships between tokens. Which tokens tend to appear near which other tokens and in what context. This is made possible by the architecture at the heart of every modern LLM, the transformer. And the key mechanism inside the transformer is something called self-attention. Self-attention allows the model to weigh the relationship between every token in a sentence and every other token. Take this example. I went to the bank to withdraw my money. The word bank here is clearly a financial institution. But change the sentence to I sat on the bank of a river, and the same word means something completely different. Self-attention is what allows the model to resolve that ambiguity by looking at the surrounding context and adjusting its interpretation accordingly. Now, a human handles that kind of context switching effortlessly. We're used to it. But an LLM can be thrown off, especially when a prompt carries conflicting signals, vague references, or missing context. When that happens, the model doesn't say, "I'm confused." Instead, it generates confidently despite being wrong. We call this hallucination. And it's not a bug in the traditional sense. It's what happens when a pattern matching system is asked to operate beyond the boundaries of its context. Understanding this changes everything about how you write prompts. In this series, I'll be sharing what it actually means to work with the grain of these models, not just throw words at them. This is the knowledge an AI generalist needs. Not just how to use these tools, but how to think about them. I'm Dr. Adil Khawaja from Intelligent Engineering Solutions. Join me every week, inshallah, and let's build that understanding together.